Hello there, everyone. Today we are going to officially introduce the sine function and the cosine function. We're going to define them and we're going to look at them a little bit here to figure out what the heck sine and cosine are. Apologize if you couldn't hear me there for a little bit. I had my microphone flipped up on my head instead of down near my mouth, and we are ready to go now, though, however. So sine and cosine, at this point, I assume you've come to realization that that deals with a curve, and a circle specifically. So there's going to be a pretty bad circle there. Let's get a better arc here. There we go. It's much better. And we've had three major angles. And at this point, we've been discussing strictly angles now and not so much reps. All right, so we have our 30-degree angle, or our pi over 6 radians, right? These are both angle measures. We'll call them theta. We have our 45-degree angle measure, or pi over 4 radians. And we have our 60-degree angle measure, or pi over 3 radians. Okay? And of course, we have 0 degrees and 90 degrees and all the other parts of the reference angles, right? 120 goes with 60 degrees because it's 60 from 180. 150 goes with 30 degrees because it's 30 from 180. 210 also goes with 30 degrees because it's 30 from 180. But the point is, 30 and 45 and 60 are our main guys. Well, the sine and the cosine function, yes, I know I'm missing some letters here. The abbreviation for sine, you just lose the E. The abbreviation for cosine, you lose the ine, the I-N-E. Okay? Anytime you take the sine of something or the cosine of something, there must be an angle. Right? This is like f of x. F of x. It's sine of theta. Cosine of theta. Okay? Sine of theta. Okay? That is an angle. We'll use betas, we'll use alphas, all kinds of different Greek letters. And of course, this would be the cosine of theta. You must have an angle at every instance of having a sine or a cosine, or even when we get into tangents and secants and cosecants and cotangents. Okay, the angle must be there. Without the angle, sine becomes just a sin. Okay, you must have an angle here to make it sine of theta. All right, now that we've established that, the sine of theta is defined to be the y-coordinate over the radius, and the cosine of theta is defined to be the x-coordinate over the radius. All right, it is that simple. Okay, so let's think back to our unit circle. You might have a copy of that available to yourself there. Let's say we are in the unit circle, so we have a radius of 1. Unit circle implies that your r value equals 1. Well, our coordinates on the unit circle are root 3 over 2, 1/2, root 2 over 2, comma, root 2 over 2, and 1/2, comma, root 3 over 2. So, if I would ask you for the sine of theta, and theta is 30 degrees, that says sine of theta, sine of 30 is y over r. Well, y is 1/2, r is 1, so I get 1/2. The sine of 45 degrees, well, that's root 2 over 2. And the sine of 60 degrees, that's root 3 over 2. What about the cosine? Well, that's the x-coordinate, root 3 over 2, divided by 1. The x-coordinate, root 2 over 2, divided by 1. And the x-coordinate, 1/2, divided by 1. Okay, there is your sine and your cosine. Okay, now you might say, well, that's the unit circle. We got to do this for every single circle? Kind of. See if you can dig out your non-unit circle, right? The radius 4 circle. And let's see what happens there. The radius 4 circle, we have the same angles on here. Okay, and remember what happened. Our triangles were just bigger. So my coordinates, instead of being root 3 over 2, was 4 root 3 over 2, which of course reduces to 2 root 3. And 4 times 1/2 is just 2. These guys are both 2 root 2 and 2 root 2. And these guys were 2 and 2 root 3. So, let's see. This is interesting. What is the cosine of 30 degrees? Well, by definition, cosine is my x-coordinate divided by radius. Divided by my radius. So 2 root 3 divided by 4, that's my radius, is root 3 over 2. Same thing I had here. That's weird. Let's try the sine of 45 degrees. Surely that can't work. Well, y-coordinate divided by the radius, root 2 over 2. That's what I had here. It does not matter the size of the circle because we are always dividing by the radius. Since the coordinates are proportional to the size of the radius, we are always looking at how quickly and how big. I apologize for the phone call there. They're just canceling school at this moment. Okay, since the coordinates are always proportional to the size of the circle because we're talking about similar triangles, when you divide by r, if your coordinates were 4 times as big, you're going to divide by 4, and they're going to get back right back down to where they were with the unit circle. So that is our sine and our cosine in a nutshell. If you know your sines and cosines, in other words, if you know your wraps, your x and your y coordinates on the circle, you are going to rock this unit. Have a nice one.